We're going to look at a trig equation in this video in which we have, you can take a look at this one over here. It says solve for the angle t that would make this true, but you'll notice that we have a cosine squared and a cosine to the first, which kind of makes getting cosine by itself a little bit more difficult to do. So what we're going to have to do is we're going to have to fall back on a method that we learned in algebra, which is solving by factoring, okay? So solving by factoring, let's go ahead and run through the steps here. You know, step one is going to be this. When you solve by factoring, it's set one side equal to 0. What we're going to be doing is essentially this. We're going to use what we call the zero product property, which zero product property essentially states that if you were to take two things and multiply them together and they come out to be 0, then either A was equal to 0 or B was equal to 0, or they both were equal to 0. So there's a benefit to being able to factor something and write it as the product of two factors and say that it comes out to be 0, because what this means is we can set each individual factor equal to 0 and then solve them individually, okay? So set one side equal to 0, we're going to say factor if possible. Okay, so it's not always possible that we can factor. We'll look at an impossible case in the next video. And then we're going to do this. We're going to say set each this thing is not very easy to write on. I apologize. Set each factor equal to 0 individually and solve. Okay, just like we normally do. So these are the steps we're going to take when we solve by factoring. And when do I use factoring? I will tell you this, you'll use factoring a lot of the time when you have, say, a squared term and, say, turn this to the first power on your variable there, okay? And I can recognize that with trig functions because I had a squared trig function and a trig function of the first power here. So let's go ahead and take a look at this algebraic one over here just with x's. You know, we say, well, the first step was get it equal to 0. We're going to subtract 5 from both sides. So we say take away 5, take away 5. There are no like terms on the left side, so it just kind of moves over. We say 2x squared minus 9x minus 5 equals 0. Now, factoring this. Now, I notice this is a trinomial where the a value here does not equal 1. And if you are curious what I mean by a value, I mean that we've studied a lot of quadratic things in algebra, and they come in this form. We say this is a standard form of something in quadratic form. So we say the a value is not 1, and the only reason I bring that up is because when we factored things, it all came back to like foiling. What we're trying to do is when we FOIL, say for example, x plus 1 times x plus 2, we do our first, so x squared, outer, so that'd be plus 2x, inner plus x, and then last, which would be plus 2. And I want you to notice this here, that these two, they kind of combine out, they add together to be this middle term. So we'd say this would be plus 3 x's plus 2. And what we basically see is this, these two numbers right here, they multiply out to be this last term right here. And furthermore, they add it up to be this middle term right here, okay? So we're looking for two numbers that sum up to the b term here, but are also, they make a product of the c term, okay? They multiply out to be the last term and add up to be the middle term. When your a value, though, is not 1, what this does is it causes it to be kind of an impossible thing to do that. We can't just say, can you think of two numbers that multiply out to be a -5 that add up to be a -9? So what we're going to be doing here is a little bit of guess and check. And what I mean by this is we're going to have to start with this. In your FOIL, this is like reverse FOIL. The first thing we want to do is guarantee that we get our first term here, which is 2x squared. So I say, well, what can I put here and here that when I multiply them, give me this 2x squared? And I would think that it'd have to be a 2x times an x, okay? So the good news is we've already taken care of the f part. Now we want to do the last part. So the last two terms, they multiply out to be this -5. So I say, well, what could multiply out to be a -5? It could be a -5 and a 1, or a +5 and a -1. And you know, I'm just going to guess. I'm going to say, you know, how about a +1, -5? I mean, I'm just throwing numbers around here, okay? So I say putting these things in, I've already guaranteed I get my last part. The only part we haven't guaranteed is that we get this -9x in the middle. So to check this, you check your O in your I's. What you do, you multiply your outer two terms and your inner two terms. If I were to do this, I get 2x times a -5 is a -10x. And then 1 times x would be just a 1x. This is going to be a -9x, which, by the way, is the thing that I needed in here in the middle. So our two factors here are these. We say, all right, 2x plus 1 times x minus 5 is equal to 0. This is like our a, and this is like our b. So what this means is we can actually set each of these individually equal to 0 now. We say, well, either 2x plus 1 was equal to 0, or we say x minus 5 is equal to 0. This had to be the case, and then we can just go ahead and do this third step, which is after we set each factor equal to 0, solve them individually. So let's subtract 1. We get 2x equals -1, and then we get x equals negative a half. So there's one of our solutions in this algebraic expression with x's, and we say adding 5 to both sides of this one here, we get to, just x equals 5. So there are our solutions here. We're going to do the same thing over here. And what I want everybody to notice is I was trying to make this as straightforward as possible. And by straightforward, I mean, you'll notice that these are cosines, a cosine squared and a cosine. But you'll notice also that they have the same coefficients as this last problem here. So we're going to treat our cosines of an angle kind of like our variables x over here. So we have, first of all, setting this equal to 0, we have 2 cosine squared of t minus 9 cosine of t minus 5 equals 0. And we're going to factor this. The only difference here is this. I say, well, starting with our first term, what can I multiply here and here to get 2 cosine squared? And I would think it'd have to be a 2 cosine and a plain cosine, because that would give me 2 cosine squared. And then I say, well, what could I multiply out to be a negative 5? And over here we used a positive 1 and a negative 5 combination. So I'll do the same thing. Positive 1, negative 5. So now I've guaranteed that term. So now we say, checking my outer and my inner, I would get 2 cosine t times negative 5 is negative 10 cosines of t. And if I were to do my inner here, I'd say plus 1 cosine of t. So adding these together, I get negative 9 cosines of t. That is what I needed in the middle up here. So here's the deal. That was kind of scratch paper work. Since I have this times this equals 0, what we're going to do is we're going to set each individual factor themselves equal to 0 and solve them individually. So 2 cosine t plus 1 equals 0. And we'll do this other one down here. Cosine t minus 5 equals 0. I'm going to start with this one down here. If we add 5 to both sides to isolate the cosine, then we would get this. We say cosine t equals 5, and t equals the cosine inverse of 5. Remember, cosine and sine never get bigger or smaller than positive 1 or negative 1 respectively. So we'd say this one, t doesn't exist. Okay, and this would be really easy to check on a calculator. If you just went into your calculator here and you said, okay, well 5, I want to do the cosine inverse of this. It says there is no number that does this. Okay, and then up here we'd say, all right, let's subtract 1, subtract 1. We need to isolate this cosine of t. So we have 2 cosines of t equal negative 1. So cosine of t equals negative a half when we divide both sides by a half. And t equals cosine inverse, let's write this down, of negative a half. Okay, so we say, all right, well, think about this. What could I take the cosine of, or what reference angle could I take the cosine of and get a half for my output value? It'd have to be some sort of 60-degree reference angle. So we're going to go ahead and sketch in all possible 60-degree reference angles up here. And we're going to say, well, if cosine came out to be negative, look here. We say it came out to be a negative a half. Then cosine is negative here and here. So the two angles must have been this angle here and this angle here. And by the way, I want these in radians between 0 and 2 pi. So what this means is if I were doing this in degrees, 60 degrees shy of 180, this would have been t, let me block this off here, t would equal 120 degrees in degrees. And we say, all right, well, this one down here is 60 past 180, this would be 240. Okay, but using what we know about, 60-degree angles, each one of those 60s is a pi third. So it would take me 2 60s to get to 120, so this would be 2 pi thirds. And it would take me 4 60s to get to 240. So this would be 4 pi thirds. Okay, so there are two angles right there. Cheers.